We call this talk Modern Automated Testing Approaches, and you have to remember I had to come up with this title a year ago, so then when I looked at it now, I said, so why did I call it that? Well, so let me tell you a story. So in our work here at Fraunhofer, we come across and we develop various testing and analysis tools because we test software clients, we infuse testing tools, like I said before, we evaluate different tools. So we do a lot of things around in this field. And so we come across a lot of tools that we found interesting, and that's what I want to share with you today. It's not really commercial for tools. I would really try to make it more like an overview of what's out there, what we have seen, and try to give you some ideas for what you might want to pick up or look for similar tools. Some of these tools, I should tell you, are commercial. Others are research prototypes. Some are widely used. Some are more unusual or test for a specific need. But they all have some interesting aspects that I think is you're going to find interesting. I know it's a lot of information in short time, and I'll be happy to provide more focused information upon request. I'm not going to spend a whole lot of time on each kind of topic, but we have a lot more information. I should also say that many of our case studies here at Fraunhofer are published and are public information. So if you search for my name, for example, you'll find a lot of information on the web that you can just download. But I'll be happy to help you find more specific information if you want. All right. So let's start with unit testing. I know it's not new, but it's interesting because it's really useful and widespread. A lot of people do unit testing. Now, with this type of unit testing, what we mean by that is the programmers unit test their own code. And what is the unit then? Well, it could be a class, a module, smaller things like that. And of course, there is a lot of benefits with the unit testing. We really want our programmers to do that, detect defects early, so we don't have to detect those defects in the integration phase, detect if we break the code during modifications. It's like a safety harness, if you will. And it's also great because they document the correct invocations and expected values, so you can actually give someone else those unit tests, and they can understand how to use a certain piece of software. Now, I just want to mention unit testing extreme, which is test-driven development or test first, which is really, they took unit testing to heart and said, unit testing is something everybody should do. Actually, according to this paradigm, no code can be written without at least one failing test. So it really means that first you write some unit tests, then you write code to match that unit test. And once that unit test passes, then you write a new unit test and write code to match that test. So there you go on. So in the end, all code has tests, and it's actually a great practice. We do a lot of code analysis here. People send a CD with a lot of source code, and they say, Michael, analyze this and say something clever about it. Does it have high quality, for example? Is it testable? And when you look at the code that has a lot of unit tests, and especially if it's done using test-driven development, you see that the code is really, it becomes testable automatically, of course, but it's also better structured, easier to read, and has a lot of good code qualities. In addition to that, when you do unit testing in this way, you kind of automatically develop a comprehensive test suite. And when you want to develop the next version of the software, you can reuse your unit test and check that you didn't break something for regression testing, and check that everything works as intended. Now, let's move on to JUnit. I just want to mention JUnit. It's not new, but what we've seen is that there's really widely spread framework for writing automated self-verifying unit test programs in Java. So it is nice because I would say it's a bottom-up feature. Programmers really like this and use it extensively. And even though we talk about JUnit, which is from Java, there are similar, what we call XUnits for other programming languages. Essentially the same, but for the other programming languages. So it's all very similar and very useful. It is open source, so it's nice, and it's also well supported by different IDEs and other tools. So it's very well integrated in the software development process. And to the right, you see one example of a JUnit test case. So it's really a test program. And what is nice with this is that you can automatically run this test program whenever you want. So maybe you have 1 million of these JUnit test cases, and you can run them every night if you want. Maybe 1 million was a lot, but a lot of people have maybe 100 JUnit test cases run on a daily basis as part of the daily build, for example. So this is a very nice practice. Now we're getting into what we really want to talk about here. So how many unit tests do we need? When are we done testing the code? And this is a question that we encounter over and over again, and it's not easy to answer either. So where we had to start is to talk about coverage, and we would like to cover all behavior of the software, but that is really hard. It's many times impossible even. So at least we need to understand how much has been covered by the test cases we have, and then over time try to increase this coverage. And I'm going to talk a little bit more about this on the next slide. Now, it turns out that it's pretty easy to measure coverage. There are several tools on the market, for example, GCov, which is part of GNU, where a lot of people use to measure coverage. So it might say, we want 100% code coverage, and you can use GCov to measure that. And that part is easy. But as I said before, it can be very difficult to achieve coverage. And it's actually impossible in some cases. Because of defensive programming. What is that? Well, say you have a case switch statement, and you only have 3 options, but anyways you add a default option, and you know that there's never going to be any options except for those 3, so you're never going to get into the default option. So it's impossible to get into and test that code, get that code to execute. And there are many other cases too that are very difficult to get to execute. Now, when we talk about coverage, the easiest is the statement coverage. It really means that every statement in the program is executed at least once. And why might we want to have statement coverage? Well, if you have a defect, I mean, testing is about finding defects. And a defect cannot hide, or if there is a defect in the code, the only way to know about it through testing is to activate it, to trigger it. And we can only do that by executing the statement. So the reasoning is, if you execute all statements, at least then the kind of shallow bugs will be detected. Now, there is a problem with statement coverage. If we take this small piece of code here, is that it's enough to, if we say input equals 1, we will actually cover all the statements in the code